Okay. Here we're cooling it. So the temperature is dropping. It's the same reaction. It's a positive delta H, so that means this is a endothermic process. That means heat is a reactant, but we are removing some heat when we cool it. So if I remove a reactant, wouldn't I move in its direction to bring it back? Okay, so that's why we are shifting left. We're going to move in its direction. The heat's going to come back up. Since I didn't have any heat to begin with because I removed it, we're going to convert the stored energy, which was potential energy, into kinetic energy, which is motion, and that motion will bring the heat back up. Okay? Okay, now, let's take a look at the practice problems. I want you to do them with the person sitting next to you, and let's see what you come up with. Okay, so let me erase that. For number 1, we're heating this. This is a exothermic reaction because your delta H is negative. So that means you've got heat as a product. And if you're heating it, you're adding more product. So doesn't that mean you're going to shift away from it so you can bring it down? So that's why you're going to shift to the left. Do we all agree on that? Okay. For the next one, you're cooling it. So you'll notice that you've got a number in the equation with kilojoules in it. Kilojoules is the unit for heat energy. So since this number is in the equation and it's on the product side, that tells you that it's exothermic. So the number will always be positive when it's written in the equation. Does that make sense? Okay. So if this number was on the reactant side, it would have been endo. Okay. Okay, so we're cooling it. So doesn't that mean this is my heat? So that means we're removing some of the heat. So doesn't that mean I need to move in its direction to bring it back? So that's why you're going to shift to the right. Yes? Okay, let's look at the last part. Let's look at the Haber-Bosch process, okay? Are you guys pretty familiar with ammonia? Yes. It's in cleaning products. It's a weak base. You'll learn about that later. Almost all of the world's ammonia is actually produced by something called the Haber-Bosch process. And it's worth a lot of money, like $600 million is produced in the world. And Fritz Haber actually developed the procedure for producing ammonia. This is the chemical reaction for producing ammonia. So nitrogen gas combines with hydrogen gas to make NH3, and NH3 is ammonia. And then Carl Bosch is the one that came along, and he's the one that put this on an industrial scale so that we could produce so much of it. Something that I want to point out to you is the delta H for producing ammonia is exothermic. So that means if this already produces heat, you want to optimize the production of ammonia by dropping the heat. Does that make sense? So you want this to happen at a low temperature because that will automatically cause it to shift to the right and produce more ammonia. Does that make sense? Okay. Now, the other thing that we should look at here is how many particles we have, because everything is a gas. So I've got 4 gas particles on the reactant side, and then I've got 2 gas particles on the product side. So then I need to figure out, do I want to increase the volume or decrease the volume of the reaction container? Okay, because if I increase the volume, wouldn't that cause me to shift to the side with fewer particles? Because if you increase the volume, the pressure drops. Or do I want to do the opposite? You tell me. Should we increase the volume or should we decrease the volume? Decrease the volume will raise the pressure. And then that will cause me to shift to the side with fewer particles, which is the right. Okay, so we should decrease volume, which causes the pressure to increase, right? And then that would cause us to shift to the right. So ideally, low temp and high pressure is the perfect scenario for producing as much ammonia as possible. Okay, so this applies everything that you just learned. Take a look at the next page. Let's take a look at the review questions. I believe you guys have got a few review questions. There's one that I don't want you to do. So on the review questions, I want you to do 1, 2, 3, 4. Do not do 5, because we already did that. And then do 6. And we're going to go over that in a little bit. For number 1, did you guys get shift left?
Yeah.
Do you have any questions on number 1? Okay. Number 2. You tell me what you put for number 2. So you heated it. Endo or exo? So this is my heat, so we are adding. So that means you would shift right. Okay. Yeah. Next page. We're just going to go in order here. So number 3, this one's interesting. Okay. A flask shifted from purple to pink. So purple's here, the pink's here. So that means I shifted which direction? Yeah, so we shifted left, and we did that when we cooled it. So we removed temperature. So does that mean this is an endothermic or exothermic reaction? Endo. Oops. And the reason why it's endothermic is because isn't heat a reactant in endothermic reactions? So if I cool it, I'm removing heat. So that causes me to shift to the left. And that's why it's turning pink. Okay. And then number 4 is what kind of a reaction? Endo. So that means heat is a reactant. Okay, so if I'm trying to produce as much product as possible, what should I do with the temperature? Yeah, so we should increase the temperature. That will cause us to shift to the right. And then what should I do with the volume? I've got 1 particle on the left and 2 particles on the right.
Why isn't heat on the other side?
So this is an endothermic reaction because it's a positive delta H. So that's why I wrote heat here. Because heat's a reactant for endothermic reaction. So if I add more heat, that's going to cause me to shift to the right and consume it.
The reactant always be on the left side then?
The reactants are always on the left. Okay, so now for the pressure, what's going to happen? Well, what do I do to the volume which will change the pressure? If you increase volume, that will cause the pressure to drop. So I need to bring the pressure back. So that will cause me to shift to the right, which will then increase the pressure and help get me back to equilibrium. Yeah.
How do you know the volume goes up?
I'm deciding. Because it says what conditions of temperature and pressure favor the products. So if you increase the volume, that causes the pressure to go down.
Then why do you want the pressure to go down?
Because if the pressure drops, then that means that I need to bring the pressure back up, which will cause me to shift to the right, where there are more products, or there are more particles to collide with the surface of the container and cause the pressure to rise. Okay, so high temp and then low pressure are this right here and this right here. Those are the conditions that you would want to produce as much product as possible. Okay. And then we're skipping number 5 and we're going to number 6. All right. So in the back, you guys tell me, endothermic or exothermic? In the back. Everybody in the back. This is exothermic because energy is on the product side. Okay, so if you add some NO, is NO a reactant or product? Yeah, it's right here. So if I add NO, I will shift where? You move away from it. So you shift left to consume some of the added NO. If you remove some NH3, is NH3 a reactant or product? Reactant. Okay, so if I remove it, I need to move in its direction. Shift left. Okay. And then the pressure of the system is decreased by increasing the volume. Okay, so if I've got 9 gas particles on the reactant side, and then I've got 10 gas particles on the product side, if I increase the volume and the pressure dropped, how am I going to bring the pressure back? Read your notes. The pressure dropped. How will I bring it back? Yeah, we would shift to the right because there are more particles on the right, and that will bring the pressure back up, and that will help restore equilibrium. You have some stuff to memorize, okay? Every period has been the same. You guys have taken really good notes, but you just don't remember what you wrote down, okay? So don't expect to remember this the night before a test. It's not going to happen. Okay, so last one, the temperature is decreased. If you drop the temperature of an exothermic reaction, which direction will you shift? Yep, you're going to shift right, because that will bring some of the heat back, and that will help get you back to equilibrium, okay? All right, I expect you to spend the rest of class time working on homework and